Let's look at working with the FM oscillator. Now, frequency modulation synthesis, which is what this is, it uses multiple signals with frequencies and they're all heard. So unlike some of the analog ones where we have these silent synced waves, these are in the audible range and they modulate each other and they create unique and complex sounds. So there are 4 operators, A, B, C, and D, and each operator has a ratio control, and that defines the frequency of that oscillator. At 1, the frequencies are the same. At 2.0 frequency, the operator is double the base frequency, etc. So let me just dial these down. We'll hear only 1. It sounds like a regular sine wave. So far, nothing too fancy. Now, the Hertz button changes the operator from relative to actual fixed Hertz values. So you can see the readout in Hertz. We're going to leave it down there and we'll leave it at 1. And let's tune this down an octave. I'm going to try and create a simple bass sound. Now the fine tune goes plus or minus an octave. And I'll option click. And when we have Hertz enabled, it switches duty and it becomes a multiplier. So you can multiply it 1, 10, etc. So let's leave that off for the moment. Phase will offset the start phase for the operator. And snap is interesting. It'll lock the ratio to harmonic intervals like 1 time, 2 time, 3 time, etc. So now we can go freely. But with snap, it's going to even amounts. And then finally, of course, we can adjust the level. Now, the idea is that all 4 are connected and this one will modulate this one, etc. Now we have a topology control here, and this is where it gets really interesting, the order that we run these in. We can go in series, we can run them in parallel and all different combinations. I'm going to start by using this configuration here where this is going to modulate this one, and then D is going to modulate C. And they're all the same, except there's a feedback level for the 4th operator. So let's bring this up and listen to the effect it has on this. Let's bring this up to 2. I can bring this up. We get inharmonic when we're working in between inharmonic tones. Let's snap it so that it'll stay in harmonic intervals. And as we alter the level, it'll change what's generated. So let's leave it somewhere around there. Now let's look at the next operator. Let's snap this as well. And then we can modulate this with the phase offset that we get by running this into this one. And then the feedback. So let's set up some modulation to modulate these parameters. I'm going to right click here and I'm going to add an envelope this time. And let's go to a regular ADSR envelope. And let's see what we can get going with this. Okay, I'm going to leave the attack pretty low. And I want to lower the sustain all the way. We're getting more of a bass kind of sound. All right, that's sounding pretty good. All right, and let's modulate this with the same envelope. I'm going to need to edit the range of that one. And that sounds interesting. Let's snap this as well. I'll leave that low. So here's a simple bass part that I've got done up. And listen to the effect of the different topologies. So they're all very different the way they're routed. It's interesting. Get an organ type sound. And this is where I started with. This is crying out for a bit of modulation. So there's a simple FM bass sound. We'll continue with more in the next video.